Hello. Today we are graphing logarithmic functions. So this is our graphing section for logs. So let's graph the exponential function 2 to the x first. So 2 to the x, if we have 2 to the negative 3, that would be 1 over 8. Right? Because we have 2 to the negative 3, that's 1 over 8. Right? Because that's 1 over 2 cubed. So 2 to the negative 2 would be 1 over 2 squared, so that's a 1/4. 2 to the negative 1 would be 1 over 2, so 1/2. 2 to the 0 is 1. 2 to the 1 is 2. 2 squared is 4. And 2 cubed would be 8. So let's plot those points. So we have negative 3, 1/8 right there. Negative 2, 1/4, negative 1, 1/2, 0, 1. And then we have 1, 2, we have 2, 4, and we have 3, 8. So this is 2 to the x. So is this graph a function? So remember a function, right? What's the definition of a function? Right? We all hopefully remember the vertical line test, but it is a function because for every x value, there is only one y value. For every x value, there is only one y value. So for every input, which is x values, you only get one output, which is your y values. So it would pass what we call the vertical line test. So if we draw a vertical line, it only intersects that purple graph one time. So that is a function. So based on your answer from part A, what must be true about the inverse of a function? It is also a function because it passes the horizontal line test. So if you draw a horizontal line, it only intersects one time. That means you have an inverse, and that inverse is going to be a function as well. So this does have an inverse function. So to create the inverse of 2 to the x, all we're going to do is take our x values and our y values, and we're going to switch them. So now this would be 1/8, and this would be negative 3. This would be 1/4, and this would be negative 2. This would be 1/2, negative 1, 1, 0, 2, 1, 4, 2, 8, 3. So the inverse, you just take your x and y values and you switch them. So let's plot that. Okay, so 1/8 is going to be negative 3 down there. 1/4 is negative 2. 1/2 is negative 1. 1, 0, 2, 1, 4, 2, and 8, 3. So this is my inverse. So we denote that as f to the negative 1. So that's the inverse. So let's graph the line y equals x. So that's a diagonal line, slope of 1, and it intersects the origin at 0, 0, and your slope is 1. So this is y equals x. So what do you notice about their two graphs in their relation to y equals x? So look at the purple graph and the blue graph. What do you notice about the two in terms of the relationship to the black line there? Well, hopefully you're thinking, oh, they're reflections of each other. And that is right. Right? They're just a reflection of each other. Right? If you take the purple graph and flip it over the black line, it would match up on the blue. If you took the blue and flipped it over the black line, it would match up on the purple. So that is technically what an inverse is. So if you have a graph and you graph its inverse, it's actually the reflection over the line y equals x. Now, when we've dealt with inverses before, well, not in this class, in other classes, usually it's algebraically and you just switch the x and y's. But graphically, when you graph an inverse, it's a reflection over the line y equals x. So I've already mentioned this a few times. All right. What would be the first step to find the equation of the inverse algebraically? Write the step down. Right? You switch the x and y values. So we have y equals 2 to the x. If you switch those, you would have x equals 2 to the y. Because that's what the first step is, to switch the x and y values. That's how you algebraically find the inverse. Okay, so we want to write an equivalent exponential equation for the following log function. So we have y equals log base b to the x. So this would be b to the y equals x. Usually we just have the y on the other side, right? We're used to seeing it like this. Right? That's what we're used to seeing. So b to the y equals x. We did that all in 9.2 and 9.3. So the key point for graphing logarithmic functions is 1, 0. So basically the blue graph, the inverse of the exponential, is the log function. So you just graph the parent function for log base 2 of x. That's what the blue graph is. So that graph, the blue one, is the log function. It's the inverse of the exponential. That's where it comes from. So the key point is going to be 1, 0, which should make sense because the key point for exponential is 0, 1. So if you switch the x and y, it would be 1, 0. So all the graphs we do now are going to be based off of that blue graph, the inverse of exponential. So y equals log base 2 of x plus 1. So this graph has been shifted up 1. So instead of being at 1, 0, the key point now is 1, 1. Now, one other thing I want to point out is looking at the blue graph, because that's what we're worried about now. Notice that that blue graph gets really, really close to the y-axis, but it doesn't touch it. So it actually has an asymptote, in this case a vertical asymptote at 0. So it gets really close to it, but it doesn't touch it. Again, remember we had a horizontal asymptote for exponential. Remember, it was always 1 less than the key point. Well, again, they're inverses of each other, so everything's just switching. So if you switch x and y's, and you had a vertical for exponential, now you're going to have a horizontal asymptote, and it's going to be 1 to the left of the key point. So since this has just been shifted up, that means I'm going to have an asymptote here at 0. So there's going to be nothing over here. Okay, so that means there will not be a y-intercept because the graph has just been shifted up 1. So I need a couple other points. So let's plug a couple points in. Let's plug in, let's say 2. So log base 2 of 2 plus 1. So this is where it gets kind of tricky because you have to remember this is a mathematical operation. It's asking you what power of 2 equals 2. That's what that box is asking you. What power of 2 gives you 2? That would be 1. So this is really 1 plus 1, so 2. So at 2, we're at 2. Okay. So let's find the x-intercept. If the x-intercept, for us to make that happen, right, y would equal 0. So 0 equals log base 2 of x plus 1. So if we subtract 1, log base 2 of x. So again, we're usually used to writing it like this. So if you want to rewrite it, you can. So 2 to the negative 1 equals x. So this would be 2 to the negative 1 is 1/2. So 1/2. So now you have your graph. So the domain doesn't get to 0, but it goes ever further to the right. So 0 to infinity. The range, that arrow means it goes all the way down and it goes all the way up. So the range would be all real numbers. And the vertical asymptote is x equals 0. So the key point 1, 0, shift that. That's your starting point. Your asymptote will always be 1 to the left, right? Because for exponential, it was always 1 below. So then after that, you can find the x-intercept. That's the second point. Right? Or maybe in the y-intercept, depending on which way. If I shift it a certain direction, you might have an x and a y-intercept. Or you can always just plug in another point. Okay, so y equals ln of x. So before we get going, remember that's the same thing as log base e of x. So from here, right, has not been shifted left or right, up or down, so the key point is still 1, 0. It means you still have a vertical asymptote at 0. Right, so x equals 0. Right, hasn't been moved. All right, so we know the x-intercept. 1, 0, there's no y-intercept. Now the problem is to find another point, your base is e. So for example, if you plugged in, let's say you plugged in 2 for x. So you have log base e of 2 equals y. So e to what power is going to give you 2? I don't know. Right, because e is 2.718, so it's some fraction. So it's going to be really hard to find a second and third point when you're doing the natural log graph. So what we're going to be okay with is just using the 1 point, knowing the graph curves something like that. So when you see base e, it's okay to only have 1 point, the key point. Because it's really hard to find a second and third point other than, trying to find the x and y intercept because the base is e. It makes it challenging. So the domain would be from 0 to infinity, and your range would be all real numbers. Okay, example 3. So now remember, when you just see the word log, that means you're in base 10. So this has been shifted to the left 1 and down 2. So your key point is usually at 1, 0, but now it's been shifted left 1 and down 2. So good news is I know the y-intercept, 0, negative 2. That means my vertical asymptote's been shifted left 1. It's always 1 to the left. So it'd be here at negative 1. Okay. So what I could do is find the x-intercept, right? If we let y be 0. So we have log base 10 of x plus 1 minus 2. So I'm going to add 2. So log base 10 of x plus 1 equals 2. So 10 squared equals x plus 1. Right? We're in single log. We go to exponential. So 10 to the second equals x plus 1. So 100 equals x plus 1. Subtract 1. So I get 99. Well, that doesn't help. Okay. Well, let's see if we can find one more point. Let's plug in 1 for x. So 10 log base 10 of 1 plus 1 is 2. Okay, now remember, log base 10 of 2 is going to be an actual number. This is asking you 10 to what power is 2. Problem with that is that's some decimal. Okay, so that's not going to help me. So what if I could figure out 10 to what power is 10? Wouldn't that be easy, right? The answer would be 1. So instead of plugging in maybe 1, right, because 1 plus 1 is 2, what if we plugged in 9? 9 plus 1 is 10. So if we plugged in 10, 10 to what power is 10? That would be 1. So 1 minus 2 would be negative 1. So at 9, 1, 2, 3, 4, 5, 6, 7, 8. Oh, that still doesn't work, but at least it gets us close to a point. There we go. So it can be challenging with logs to find that second point. Usually I would recommend finding the x-intercept or the y-intercept, but sometimes that doesn't work. So again, I was thinking that I'm working with base 10. So if I could get 10 to some power equals 10, that's a nice, easy number. I knew that would equal 1. So I plugged in 9 to make this a 10 right there. So 9 plus 1 is 10. So your domain would be from negative 1 to infinity. Your range would still be all real numbers, which is always going to be the case. Wait, last example. I'm going to move this 2 back here. So you have y equals negative log base 2 of x plus 2 plus 2. So this has been shifted left 2 and up 2. So instead of being at 1, 0, go left 2 and then up 2. And then that means my vertical asymptote is now at negative 2 because it's been shifted left 2 as well. So hopefully you should be able to tell me what the range is already. Okay, so this is going to have an x-intercept and a y-intercept. Now, what is the negative going to do? Right? So think about it. What is that negative going to do to our log? Because it's going to be different than the last 3. So to find the x-intercept, right, we're going to let y equal 0. So 0 equals negative log base 2 of x plus 2 plus 2. So subtract and divide by negative eventually. So you have 2 equals log base 2 of x plus 2. So 2 squared equals x plus 2. So 4 equals x plus 2, so x equals 2. Okay, so then the y-intercept would be next. So we're going to x equals 0. So we have negative log base 2 of 0 plus 2. So negative log base 2 of 2 plus 2. Now, again, this is an actual mathematical operation. It equals a number. This is asking you, right? 2 to what power is 2? That's 1. So this is really negative 1 plus 2. So it's 1. So the graph is actually going down. So to find my x and y intercepts, right, plug in x for 0, y is 0, so the x-intercept was 2, 0, the y-intercept was 0, 1. The domain would be from negative 2 to infinity, and the range is all real numbers. So again, remembering the key point is 1, 0. Shift that. Your asymptote's always 1 to the left. After that, I would probably try to find the x and y intercepts. Probably the easiest way to get your second and third point. Now, with logs, you're not always going to be able to get that second and third point, depending on what the base is. So example 3, the base was 10. It was really hard to get a second point. Number 2, the base was e. That was hard to get a second point. So sometimes you might only have 1 point, but you need to try to get a second and third one. But notice all the graphs have a vertical asymptote. They always start and go to the right. If it's positive, it's up and to the right. If it's negative, it's down and to the right. Notice the range was all real numbers for all of them. The domain is always from the exit or the vertical asymptote to infinity. So to finish up your notes, make sure you answer the essential question. All right, when you're writing your summary, 3 to 5 sentences, and you'll be done. Have a wonderful day.